So in class we did this question, and it was a 2D collision question. So we have a 1,000 kilogram car approaching an intersection traveling north at 20 meters per second, and a 1,200 kilogram car approaches the same intersection traveling east at 22 meters per second. The two cars collide at the intersection and they lock together. Ignoring any external forces that act on the cars during the collision, what's the velocity of the cars immediately after the collision? All right, so I'm going to go over the solution that I did, and I'm also going to create a new solution because I think that some people found this, my method of doing it, a little bit confusing. So I'll do it a different way as well. Okay, so because the question says the two cars collide at the intersection and lock together, this would be an inelastic, meaning the two objects are stuck together. So when you set up the problem, we started off by drawing what's happening here. So we have one car that's traveling east. It's a 1,200 kilogram car going 22 meters per second. Another car traveling north. It's a 1,000 kilogram car and it's traveling 20 meters per second. Okay, so now these two cars collide. So we have the initial velocities and the initial masses of each of the cars, and when they collide, now their masses are going to be combined as one object because they're stuck together. So I've started off by saying that total initial momentum is equal to the total final momentum. Now we have two objects, so we have momentum 1 initial plus momentum 2 initial is equal to the total momentum of the two cars, which are stuck together. The formula for momentum is mass times velocity. So we're going to find momentum 1, which would be m1v1 initial plus m2v2 initial equals their masses combined, m1 plus m2, times their final velocity. So since they're stuck together, we only have one final velocity because the two objects are stuck. We're treating them as one big object with a mass of m1 plus m2. So when I solve for v final, I get m1 v1 initial plus m2 v2 initial over m1 plus m2. Okay, so that's all fine. Now, when we go to actually solve the problem, I plugged in v1 and v2 initial as 20 north and 22 east. Now, some people did something similar to this, but they added the numbers straight up. So when you have 9.0909 north plus 12 east, they were just adding the numbers to get 21.0909, for example, okay, in a similar question like this that was on the text. So I want to make sure that you're understanding this. So when I get this 9.0909 Newton meters per second north plus 12 east, what I'm doing is adding the two components as vectors. So I have one going north, which is 9.0909, and 12 going east. So when I add them, I need to add them using Pythagorean theorem because north and east are perpendicular to each other. So I'd be using Pythagorean theorem. That's what I did on the side over here. I solved for my hypotenuse, and then I found the angle that was over here using tan theta equals opposite 12 over adjacent 9.0909. Okay, so that was the one way of doing this question. I'm going to now show you the other method, which I think maybe other people will find easier. So because this is a 2D collision, so we don't just have one object going right and another one going left or up and another one going down, for example. We've got one object going east and the other one going north. So we've got two different dimensions here. It's a 2D collision problem. When we have questions like this, what we can do is just separate it into the x and y components. So I'm just going to call this method 2. Okay, this is on, like, written on the solution notes as well. So you'll see this there. And so with this method, what we're going to do is just separate the x components and the y components. So maybe I'll make a table here just to organize everything better. And in terms of mass, those masses are not vectors. The masses are scalars. They don't have a direction. So I don't need to worry about putting masses into this table here. But for velocity, I'm going to have v1 initial and v2 initial. Okay, so the velocity of the first car and of the second car. I know the velocity of the first car. I'll write it off to the side. Velocity of the first car initial. We said in the question it was the 1,000 kilogram car approaches an intersection traveling north at 20 meters per second. So that's the one that I referred to as my first car, and that's the velocity of the first car then is 20 meters per second north. And if I were to draw what that looks like, it would just be a vector pointing in the north direction. Okay, so if I want to find the x and y components of that vector, what would they be? So since the vector is pointing just north, the x component is 0 and the y component is 20. If I do the same thing with the velocity of car 2, the 1200 kilogram car, initially leaning before the collision, it's traveling east at 22 meters per second. So I would write 22 meters per second east. And if I were to draw that as a vector, it would look like this, right? So the x component of that is 22, and the y component is 0. Okay, so now we know the x and y components of both of the initial velocities. So now I'm going to start with one of the directions. I'll start with the x direction. And I'm going to use the formula that I had already started off with. So I can start off with my P total initial equals P total final. And now I have my momentum of car 1 initial plus my momentum of car 2 initial equals my momentum of both car 1 and 2 all final. Okay, so I have M1 V1 initial plus M2 V2 initial equals M1 plus M2 V final. Okay, so far this looks exactly like the other method I was doing. I can solve for my V final, and I get M1 V1 initial plus M2 V2 initial over M1 plus M2. Okay, but now I'm only worrying about my x components. So my V1 and my V2, okay, this is V1 initial and V2 initial. I'm only using the x components, so just these two values here. So that's what I'm going to plug in here. So this is really my x component of my V final, okay? So if I plug in all my numbers, my mass 1, I'm talking about the first car that has a mass of 1,000. My V1 initial, let me just make some more space. My V1 initial is from the table 0 plus my mass 2, which is 1,200 kilograms, times my V2 initial, which is 22, over the total mass M1 plus M2, which is 1,000 plus 1,200, 2,200. Okay, so I can use my calculator. And I get 12 exactly. So now my V final in the x direction is 12 meters per second. Okay, so I can do the same thing now, but I'm going to look at the y direction. Now I don't really need to start all over. The formula is all the same, so everything on this side is all equivalent until I get to this where it would be V final in the y direction. Everything is still the same here, but I'm looking at the y components now. Okay, so I'll plug everything in. So mass 1 is still 1,000. V1 initial, now I'm looking at the y components, so I'm looking at these numbers. V1 initial is 20, mass 2 is 1,200, V2 initial is 0 over 1,000 plus 1,200, which is 2,200. So I'll just type this into my calculator now. And I get 9.0909 meters per second. So now I have two components of my velocity. One component is the velocity, final velocity, the x direction is 12 meters per second. So that looks like this, a vector going in the x direction, 12 meters per second. Another one in the y direction, so it looks like this, 9.09 meters per second, okay? And it doesn't matter whether you draw it that way or if you draw the y first, 9.0909 meters per second, and then the x after 12 meters per second. What matters is that you draw the vectors tip to tail. And then the resultant would look like this. This would be my V final, or like this. This would be my V final. Either way, I'm going to get the exact same answer. So I can solve for the angle here. I'd say tan theta equals opposite 12 over adjacent. And I would take my tan inverse there of 12 over 9.0909. And I get 52.9 degrees. So my final velocity then, I would say V final is equal to that hypotenuse, which I need to solve for. So the hypotenuse, which would be the square root of 9.0909 squared plus 12 squared. So I'm just going to plug that into my calculator. And I get 15.1 meters per second, and the direction would be north, 52.9 degrees east. Okay. If instead I found the angle in the first drawing that I made, this was 12 meters per second, if I found this angle instead, I would say tan theta is equal to opposite 9.0909 over adjacent 12. Solve for my theta, I get tan inverse of 9.0909 over 12, and that gives me 37.1 degrees. So then I would end up with a V final of 15.1 meters per second, and I would say, oh, it's east 37.1 degrees towards the north. And both of those are equivalent. So east, from the east going 37.1 degrees towards the north is the same as going from the north 52.9 degrees towards the east. So either way, we're correct, okay? So there's this answer, or there's this answer, and they are both the exact same answer, okay? Both would give you the same correct answer. All right, so I hope this makes this question a little bit more clear. You can choose whichever of these methods makes sense to you when you do a question, if and when you do a question like this on your exam. Okay, I hope that helps. The solution is all written out in on your solution page of your notes. All right, I hope that helps. Thanks for watching. Bye.